Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. Up to now we've used the F-test to ask, do the regressors matter jointly? In this video, we're going to go one step further and we'll use the F-test to answer, does a more complex model really improve on a similar one and a simpler one? So, does the more complex and this is called model comparison. Now, model comparison using the F-test applies to, in a sense, also nested models. This means that one model is a special case of the other, and the simpler model can be obtained by simply imposing restrictions on the more elaborate model. What we will take away from this is that the simple model is what we're going to call as the restricted model. And the more complex model, we're going to call as the unrestricted model. How to show that more practically? Well, suppose that you have a very simple model. So this would be your restricted model. Y equals to some beta null plus beta 1 x1 plus an error term epsilon here. The unrestricted model would look something like y equals to beta null plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 and then an error term u here. The restricted model, as you can see, contains x1, which is already in the unrestricted model, and then the unrestricted model contains x2 and x3 on top of the restricted model. So the question here becomes, do these x2 and x3 matter jointly? Do they add value jointly? For this particular case, and in general for model comparisons, then your null hypothesis becomes that the restrictions are true, which formally we will simply write as, in this case, beta 2 is equal to 0 and beta 3 is equal to 0. So we're going to concentrate only on the ones that we are looking into jointly adding value. And the alternative hypothesis, which is at least 1, is different from 0. So we're saying at least one restriction is false. So keep in mind, this is not about one coefficient, but it's about the group of variables together, in this particular case, x2 and x3 together. So what is the F-test then really comparing when we're doing this model comparison? It's going to compare how much unexplained variation remains in the restricted model. So how much unexplained variation remains in model versus the how much unexplained variation remains in unrestricted model? If adding variables barely reduces the residual sum of squares, then it's very likely that what we're seeing is this extra complexity isn't really worth it. But if the RSS drops a lot, that means that, well, the variables have their own place in this regression. So the F statistic in this case will ask, is the reduction in unexplained variation large relative to what we'd expect by chance? And keep in mind, it scales. So the drop, you have to look at the drop in the RSS. So drop in RSS. And by the number of restrictions, because if you are adding more variables to your regression, that means that the degrees of freedom in the left-sided block of your data output is going to change. And the other thing by which it scales this drop in the RSS is also by the remaining degrees of freedom. Because also the remaining degrees of freedom, which we calculate as n minus k minus 1, are going to change. And you've already seen the logic of how these elements link together in the previous exercises. Just because now you're doing model comparison, you're still using the F test, so you're still using F statistic, and the rules for your decision are still going to be the same. Any large F values, especially larger than any critical value that you have, you reject the restricted model. If you cannot reject it, meaning very likely you have a very small F value, it means you should better keep the model simpler. So keep in mind, model comparison is not about maximizing the R squared, okay? It's about justifying complexity. Which kind of relates also to another concept that we have seen in previous videos. When we looked at the difference between the R square and the adjusted R square, we said that the adjusted R square is actually more appropriate when we are doing model comparisons because the adjusted R square penalizes models that add variables without improving the fit enough. So in a sense, the F test, when we do model comparisons, formalizes what the adjusted R square had already suggested. Where does this appear in practice? Keep in mind, model comparisons with the or by the F test is used when you're adding control variables, when you're testing functional forms, when you're comparing a baseline model to a more extended model. And you actually see this in empirical papers all the time. The F test lets you decide whether a more complex model genuinely improves on a simpler nested alternative. So whenever you run into an actual example where you have to, for instance, come up with the best model that describes the variation in your Y variable, you might also be aware of the values that you see in your F, or conducting some joint hypothesis testing to see what is really going on with the dynamics with the different variables that you have added. And with this video, you now have a little bit of a better overview how all of these elements link together. So sum of square, R square, and adjusted R square, joint hypothesis testing, and model comparisons. Keep in mind, these are very important tools used to move from running regressions to choosing models responsibly. In the next video, we'll see an applied example to model comparisons and how we can do that with the F test, because at this stage, we're going to have to introduce one additional formula for conducting an F test. So stay tuned, and I'll see you in the next video.